First of all, thanks to Dgraph organizers team to let me talk to you about my side project Will and Go, and obviously thanks to all of you who are listening, and I hope you're all doing well. Before dive into the subject, let me introduce myself and make my self-promotion to you. My name is Sylvain Combraque, I'm from Lille in France. Then, sorry for my baguette accent, but I'll try my best to speak as well as possible. I'm Traefik contributor, I'm also creator of the cache system we'll talk about, and you can find me on GitHub, searching Darkwik and Darkwik Dev for Twitter. I'm working in a company called Les-Tilleuls. It's a French self-managed company, and we are working mainly on web stacks like PHP and React.js, but we are working on Go softwares too. So let's replace the context of why I started to dev using Golang and how I came to do it. As I said, I'm Traefik user since 1.4, contributor and helper, and for those who don't know Traefik solution yet, it's a reverse proxy created to manage container architectures, and it's a container-first approach. It supports the hot detection deployment, the scaling, it load balances your request automatically using the wait one robin system, and use only a specific port for all protocols. Then Traefik manage for you the service resolution depending on host in entry. Then it's a pivot point of your infrastructure. It's like Kong or Nginx for those who have already worked with them, or like Caddy also, but really simpler to configure and to set up. Another good point is the fact you can install it on your development environment and continue your work instead of bigger reverse proxies like Kong, for example. Then, as you can hear me, I love to use Traefik, but after months to use this solution, there was an issue I was facing too. There wasn't any cache system internally to Traefik. Then all requests would have to resolve the associated service. Then it took many milliseconds to be done. I searched after a cache system solution, but nothing appeared to be as efficient as I wanted, or it was only POC. And after many nights spent to look after that, I decided to create my first program in Go. I was totally noob with this language, but it didn't scare me because I had a goal, and for every kind of project, when you have a concrete goal, you'll do your possible to achieve that as any possible ways. And it's different to start a language with a goal and learn a language through a tutorial. You are more implicated in your development. So that's how I came to learn Golang with all of its dark sides and obviously all of its light sides. This project called Souin is actually in 1.4.4, and for the record, the release names are free beer names, open source beer names, precisely, because I love to drink beers. So don't forget to leave a star because I've got an oversized ego, and it makes me happy to view the Stargazer's count growing. For those who are using Varnish, there is an illustration to show you how Souin is versus Varnish. And obviously that's just for trolling, and I send kisses to Fabpot. So let's see together how it's easy to set up Souin through a demo. So here I'm in a folder with a configuration YAML and Docker Compose YAML file. So if I try to catch the configuration YAML content, we are defining a default cache key with a children named port to define that Souin will listen only on HTTP. And we are defining a TTL with a lifetime of 10 seconds. Then we are mapping the reverse proxy URL using the Docker service name because they are in the same network. And if I clear that and cat the Docker Compose YAML file, we are defining the first service, which is Traefik, then the ports mapping are not important, and we are defining OMI service, which is a container which will show us what's the IP of the container or any other things. And we are defining a Souin instance as latest, which will listen on the HTTP port, and we are mapping the configuration. So if I try to make a Docker compose up with detached mode, then containers will be running and will be starting. So it creates the containers because it's Docker compose, and it's a little bit laggy because I'm recording at the same time, but everything should be okay now. And if I try to reach the domain.com, which is mapped to Traefik, we can see it took some milliseconds, and if I try to refresh, it takes less milliseconds, but it's a higher number than the production mode because I'm recording in the same time, etc. And as you can see, it's really easy to set up instead of varnish. Now let me explain how to build fast application with Go and specify in my case which kind of Go features help me a lot. First, I can't talk about Golang feature without mentioning the Go routine feature. If you don't know that, a Go routine is basically a part of a thread which will run one task, one function, detached from the main thread, and will close if the main thread stops. In this example, we can see that the cost function will be delegated to another thread to be more efficient, and because we don't need the result of this execution, we don't store in any variable. Then here the update cache eventually is really cost effective due to headers validations, RFC checks, and other checks. And you can easily do concurrency with the Go keyword placed before function declaration and before function usage. Then another big feature is the channels. We can wait in main thread for informations or push data to the Go routine. Today, a real Golang application without channels and obviously Go routine doesn't exist, or it's really rare. A channel is like a bridge between the thread that instantiates the channel and the associated Go routine. For example, I use channels to thread the incoming request and be able to coalesce them if needed. And only when the response is available, I return it to the client. With that, I can manage multiple connections at the same time on different or same endpoints. And as a channel, as a type, we can define our OR channel channels like here. We are defining a reverse response channel that can take the same type as input-output, and you can only pass and retrieve reverse proxy type or nil. And a little tip, you don't forget to close your channels. For the record, in the previous version, I forgot to close the channel at the end of the function, and there was a higher memory consumption. Then for those who are asking in their mind, on lines 22 and 32, I manually closed the channel. I couldn't use the defer keyword just after the responses variable assignment because I have to close it as early as possible. Then if the response is valid, I can close it to avoid memory pollution. Then I was facing an issue that Go doesn't support generic tabs at the moment, but in the second version of Go, it will be done. So we have to find some tricks to be able to pass as a generic object as possible. The solution is to apply the dependency inversion principle to decoupling software modules, thanks to Wikipedia for this definition, and use interface instead of the implementation. It's a little bit tricky to implement an interface in Go because you don't have the implement keyword, and sometimes you can implement an interface under the hood without knowing you're implementing it. In Souin, we have some providers to be able to let the user decide which kind of storage system should be used, depending the matched URL in the full version. And here we are defining the type of each provider. Each provider defines the same functions, like list keys, get, set, and other ones. And for each provider, these functions have the same signature. So to make a generic object, we can define an interface like the abstract provider interface, which will contain the method's signature, and each structures defining all the functions with the same signatures will be considered as implementing the interface and can be part of an abstract provider interface, for example. After that, we can pass our Redis and our Ristretto provider, and as the two structures are implementing the interface, it won't crash, but your IDE will show you the auto-completion for an abstract provider interface object and not your real object instance method. The power of Souin compared to Varnish is the configuration part, which is simpler than the VCL or Varnish configuration language. Here you just have to define a YAML and it works like a charm. On the left you can find the minimal configuration to be able to run a Souin instance, and on the other side you have the full configuration for the full version containing Redis provider, etc. Then as it's YAML, you can use anchors, you can write scripts to create dynamically the configuration, and the most of all, the configuration supports the hot reload. Then you don't have to restart Souin if you change the configuration, but I plan to disable it by default in the future to avoid memory leak, and because it makes a side Go routine running to listen the file changes and reload configuration when the file is saved. Then keep in mind that the existing keys are always stored and available in your providers and will be purged only when the TTL reach 0, or if you decide to purge the cache by regex or URL directly using the API, but we will talk about it later. As Traefik, Souin is container first designed to be compatible with as much as possible with existing systems. You can define a Docker compose YAML file for Souin, exposing the needed port, and map the configuration file path to the Souin container, and be sure the reverse proxy is in the same network than Souin instance to avoid the external request. This is the configuration for working with Souin out of the box. There is an available CatG module and the Traefik plugin, which will be released when they'll support plugins that use the unsafe library. I hope this day will arrive soon, but I don't know when. So it was so funny to dev this, but I was facing the most complex part. The first one was the RFC implementation and RFC support. Because supporting a RFC rule is really good to face and fight the depression, because you think you're done with that, but another rule comes and you have to rewrite parts of your code. The RFC for request for comments designs the semantic of the web and apps to homogenize and define standards of your responses, your behavior, and don't let the creator be free about implementation, like the logical parts and data processing, for example. And here is an example with the RFC 7234 single page, and there are 42 other pages. And that was a pain to support that, but thanks to other developers that implemented it partially in the past, I could reuse their existing work. Then, when you're implementing an RFC, you realize that just if-else conditions, you can see in this example to manage the cache control header. It's just conditions after others to be able to test every cases. And that's the same, for example, for the expire header to check if it had already expired or always good to be served, for example. Another cool feature is support for the request coalescing. That means when you get multiple requests at once on the same route with same context, you'll temporize all incoming requests and you'll request only once your backend, then use the same response for all temporized requests. That's pretty cool because your backend service can be on cheaper server like a Raspberry, for example, and it couldn't handle all requests if it was than if it was on Fortline. So thanks to Single Flight for providing a library that can be used to handle and coalesce requests. As Souin takes care of users and want to let them manage the cache through an API, it provides some endpoints and secures them with authentication. At the moment, you can only list keys to avoid content linking and purge cache for resource or multiple by regex. So let's see together how it works and how I did it to make it faster as possible without impacting the base cache system. First, the configuration about all the API endpoints are the following. You have to define the API block in the YAML configuration file. Then you can override the main bus path, which is Souin API by default. And at the moment, Souin supports only 2 APIs, but in the future, it will support more endpoints. For each endpoint, you can override the bus path, tell if it's enabled or not, and by default, it's not. Then, specifically for the security endpoints, you are allowed to define a secret and a list of users to be able to log in as these users. For the user endpoint, you can tell that you want to protect related routes behind JWT security firewall. For the cache management, the default bus path is Souin, and you can send a GET request on the base endpoint to list stored keys or send a purge request on an ID or reject purges. Here are some examples about the results when you are sending requests on these endpoints. As you can see, the bus path route returns an array containing all keys stored in the provider. And in the full version, it returns all keys for each provider as an associative array. The provider name will be the item name, and the item value will be the stored keys for this provider. The purge regex path returns nothing except an HTTP no content header to tell you that the purge is taken in consideration. So, as I said, Souin provides the JWT authentication using JWT token, and you can log in on the login endpoint sending a post request, a JSON content type header, and a JSON body containing the username and password. Then you can refresh your token sending a simple post request with a JSON content type header and a cookie called Souin authorization token, which contains the JWT token in it. Here is the result about the security API endpoint, which is located under the bus path authentication by default. The login request set on HTTP cookie if authentication is valid. Then the refreshed endpoint returns a new HTTP response, which tells that the previous cookie should be replaced by the new one. But you can tell you in your mind, okay, it sounds good, but I want to know how to cut this. So I'll tell you the magic under the carpet. Basically, I get the main bus path from the configuration. If it doesn't exist, it will use the default value Souin API. Then after that, I load each endpoint using the initialize function, which take a provider and the configuration. If the endpoint is marked as enabled, I just create an HTTP handle func with and without the trailing slash. And each endpoint have a property named handle request as the name specified to handle the incoming request. Then the path is built from the concatenation of the main bus path and the endpoint bus path. This code is running at the Souin startup or the configuration warmer, and it takes only some milliseconds to be executed. Then the last tricky part is the key management. I'm using a Ristretto library, but in Ristretto there wasn't a function or property containing the full list of stored keys. Then I had to declare it out of the Ristretto library. I called it key saver in the Souin codebase. So it allows you to manage the keys with the hash key, the hash name in the Ristretto library, and as value the plain key. Then the key saver is basically a Go routine, and all actions on it will be run inside it. And get and delete functions are asynchronous. And with this approach, I don't have any problems with concurrency as I try to write something in the array while I'm reading it. So thanks to the rlock and rnock functions to ensure nothing can edit your list when we are accessing it. So after this very long technical part, we can now talk about the deployment system. The deployment is secured by Travis CI to avoid any regression. Then the GitHub action get back the lead to deploy only tagged version on master and full version branches. So first, the workflow for deployment or on tag branch is the following. Tests for Travis are launched, then the artifacts are built, and the last step is to upload artifacts on the tagged commit to be able to download the OS and Arch associated by now. So here is a diagram to try to represent the Travis CI setup, and here is a configuration file about it. Let's see together what's done on it. First, I tell Travis to boot with a Golang environment. Then I add the Docker dependency to be able to run required containers. Then it ensures compliance with every system. And I decided to not sending emails to not being spammed. After this setup, Travis will run the make create network command to add the associated network, then make build dev command to prepare the container to run as development mode. After that, after all these steps, Travis will run the make validation command, which will group the linter verification, and if it succeeds, it will run the test to handle any regression. Then, after that, we check that the production mod can be built and won't crash to ensure the compliance with users that use the latest Docker image. After that, when it's merged on master and tagged, the GitHub action will be called and two jobs will be running. The first one is the binary generation to create artifacts depending the OS and Arch. It retrieves the tag name, pulls the tag branch require Docker dependency and enable the build system to be able to build Docker images. Then it tries to log into the Docker Hub using secrets credentials and build the prod container using the Docker file prod and push it to the Docker Hub as latest full and tag branch name as image name. The only one line which differs from the minimal version is the 33rd line. In the minimal version, we are using latest instead of the latest full tag. And as you can see, here is the result on the Docker Hub. Our image is tagged as latest and is ready to be pulled, and obviously is tagged as the latest full for the full version. Then the last steps is the artifact generation and upload them to the GitHub release through the Go releaser action. In this example, we build for Linux, Windows, and macOS for each arch to handle most cases, and it uses a matrix to build the tool. And as you can see again, we have our artifacts on the referred release. Then every tests are and deployments are done. We can pass to the last part, which are the metrics, and for those who want to see what is the power and performances of Souin. Here are some metrics to view how many requests it can handle per second. It took around 35 seconds to serve each 101,000 requests. The max response time was 56 milliseconds, and the minimum one was 0. But in fact, it took around some microseconds, but it rounded to 0 milliseconds. And it's due to Ristretto powerful in combination with the asynchronous updates. So what's next in Souin? There will be a fully support of Vary. It required a deep refactoring about stored keys, and it took some time to achieve that. And we worked on the fact Souin shouldn't try to coalesce request on an endpoint that already returned a private cache directive. These features are already available on master branch. And after that, we will support the new RFC cache status to replace the X from cache header. And there is always the work on performances because this can always be optimized. Then I plan to release a new stable version on this week, and obviously if you want to contribute, you're welcome. So let's see together some another cool side projects. The first one is Merch. It's an open source pen test oriented platform to help pen testers to get enhancement on their missions. You can find it on GitHub, and I built a platform for discover KDE modules and simplify the life for making a xkd build command. You can contribute on the website, which is located in xkd.tech, and on the build on the module retriever. These projects are available on my GitHub. So to finish this talk, I just want to say thank you again to Dgraph organizers team. Thank you to all of you who are listening me. And don't be shy, you can ask me whatever you want. I'll try my best to answer it in the chat. Anyway, I'm available on Twitter if you find some question during the night. And like Gordon Ramsay is saying, thank you.